part of our astronomy unit, looking at the solar system. And tonight we're going to look at some of the objects that make up our solar system. We're going to start with the planets and then work our way out to other objects. So first off, what makes a planet a planet? What are the criteria necessary to be a planet? So, criteria to be a planet. Alright, and there are three things you have to be a planet. You must be in orbit around a star, but not be a star yourself. So that takes care of moons because they don't orbit a star. And we'll see next week after our test that there are also some star systems that have two stars that orbit each other, called binary star systems. Right? So neither of those can be a planet because they're both stars. The object must be massive enough for its own gravity to pull it into a nearly spherical shape. So when things get really, really big, their own gravity becomes strong enough that it pulls them into a round shape. So things like Earth, Mercury, Venus, right? These are all round objects. And finally, the object has cleared the neighborhood around its orbit. So this is pretty much the only object in its orbital neighborhood. Right? And the reason that Pluto is not a planet is it has turned out to be just one of many objects in its orbit. Right? So you're going to take your own notes for this section. Right. So those are our three criteria to be a planet, and you should be familiar with those. So let's quickly look at the different planets of our solar system. We're not going to go into a ton of detail. So we have the inner planets. You guys are going to keep taking your own notes. All right, the inner planets are made out of rock and metal. So Mercury, Venus, Earth, and Mars. The surface of those planets is rock and metal. And I know the Earth has oceans, but underneath those oceans is, of course, more rock and metal. So we're looking at what the main structure of the planet is. These are much smaller in size compared to other planets, and they orbit relatively close to the Sun. All right, as we saw in our, or will see, depending on which class you're in our activity in class, right? When we looked at the scale model, Mars was only like 1.5 meters away if Earth was 1 meter away, whereas Neptune we saw was like 30 meters away. So the outer planets definitely are much, much, much farther away. Looking at those outer planets, all right, you guys are going to keep taking your own notes. All right, Jupiter, Saturn, Uranus, and Neptune. All right, these are composed almost entirely of gas. All right, they have a small solid core way down in the center, but most of the planet is gas. Gas is like hydrogen, helium, and methane. All right, gas still has gravity, it still matters, so it still pulls itself together into a round shape. But if you tried to step onto Jupiter, you would fall all the way in until you hit the center, and that would be bad. So these are much larger and farther from the Sun as a rule. So let's look at some other stuff that's in our solar system besides planets. We've got the asteroid belt. All right, so the asteroid is a region between the orbits of Mars and Jupiter. So here's Jupiter, here's Mars, right? And you've got this range of stuff in there, all right? And these are asteroids, chunks of rock that also orbit the Sun, but they're too small to have pulled themselves into a round shape. All right, so they might look like a potato, they might have funny angles. All right, they're going to be anywhere from a couple hundred meters to a couple of kilometers across. Should spell asteroid belt correctly over here. That would be a good start. Farther out, we have what's called the Kuiper belt. All right, spelled kind of Kuiper, but pronounced Kuiper. It's named after the astronomer who predicted its existence. So the Kuiper belt is just beyond Neptune's orbit, and it's basically, you can think of it as a second asteroid belt. So we have the first asteroid belt inside of Jupiter's orbit. Now we have the Kuiper belt just way farther away. And it contains asteroids, some dwarf planets like Pluto, and then a lot of just small icy objects. It's so far away from the Sun, it is really cold out here. So things tend to have a lot more ice on them than asteroids did closer to the Sun. And then if we go super far away, we get to an area called the Oort cloud, again named after the astronomer who predicted its existence. The Oort cloud, right? And this is, instead of a ring, is a kind of spherical shape, right? So each dot in this represents an object in the Oort cloud. Right? And this is more than 1,000 times farther away from the Sun than Earth is. So you can see here is our solar system. Earth would be way down in next to the Sun, and this whole image here fits down in that tiny little rectangle. So the Oort cloud is super far away. We don't really know much about it, except we do know that a lot of comets that we see in the sky come from the Oort cloud. They have super long, crazy orbits that bring them from way out here, way down into the Sun, and then back out. Speaking of comets, yeah, there we go. Nope. Ta-da! Comets. Alright, so a comet is something that we see in the sky, and it's basically a giant like space snowball. Alright, it's made up of frozen gas, ice, and dust. Alright, so it's just a little like junky snowball in space. But when its orbit brings a comet near the Sun, some of that gas and ice melt and create a tail. So looking at this picture of this comet, right? The actual head or nucleus of the comet is right in there, right in the middle there. And then the melting gases and melting ice create this tail that runs off of the comet. Right? And that's called the coma. You don't need to know what the tail is called. But this was a really famous comet called Comet Hale-Bopp. It was so bright when viewed from Earth that it was visible even during the daytime. So different comets obviously are going to have different brightnesses depending on how close they get to Earth. So the last thing we're going to look at is meteors. Alright, so there's lots of junk in space, and sometimes, or in fact often, almost every day, small pieces of space rock fall into the Earth's atmosphere. Right? As they fall in, they're going like 20,000 miles an hour. So if you rub your hands together, you can feel that they get hot. Your hands are going like 3 miles an hour. So imagine how hot this gets. So friction heats up the rock as it falls in, and most of these rocks totally burn up as meteors or shooting stars. So when you see a shooting star at night, that's what you're seeing. Some piece of junk falling into the Earth's atmosphere, heating up and burning up. But occasionally the rock is so big that even though a lot of it gets burned away, some pieces are left over and hit the ground as meteorites. Right? And these provide us with some clues about what other kinds of objects are in the solar system. They tend to be mostly metal. They have these really pitted out surfaces from when they were burned in the atmosphere on their way in. But they can kind of give us some clues about what else is going on in the solar system. So when you see a shooting star at night, know that it is not actually a star moving across the sky. It's a tiny piece of rock falling through the atmosphere and burning up. Alright, so go ahead and write 3 questions at the end that we can go over in class next time. And I will see you guys in class either on Thursday or Friday.